Hi, I want to try and sync 2 or more interplanetary file system files using a smart contract as an intermediary. Let's go. Okay, so here I've got a template app. So first things first, I'm going to need some input to get the data to put into my file. So let me just flesh that out. For the data, I'm going to use a UUID for the key. The identifier for the message needs to be globally unique. Here we go. So I've got a input and we submit that, and then we generate an object with the UUID as the key, a little timestamp and some text. So the goal is to create a file with a bunch of these objects, each with a UUID as their key, and then submit that to the interplanetary file system. And then on another interplanetary file system instance, create another bunch of objects with UUIDs as keys, and then submit to a smart contract the interplanetary file system name service hash, and then programmatically sync these message objects. So now I'm going to write some code to submit this data to the interplanetary file system. Okay, so I've filled out the functionality. So we've got a function that starts the node using this create, and then we've got a bunch of inputs here. So let's start by making some data, message A, submit, B, submit. Next, we're going to want to create a file. So let's go to this files API, and we will actually be using add instead of the write. If we look at the write function, we don't have an option to overwrite the file. So we create an object with the path and the content, and then we call this function here. And that add file function takes this data and then adds it to the interplanetary file system. And in response, we get this CID hash. I've got this input here. As soon as I hit this return, I call this function cap file. So my implementation just adds these chunks of data to an array. Once all of the promises have resolved, we turn that array into text data. Here we are, we've got the contents of this file. So next we want to publish this CID to the interplanetary name server. So that's in the documentation here. We want the function publish. It's very simple. Down in my UI, I have this text input, and then I call this function publish, and here I get the information. This is my IPNS. So if I then use another function, resolve, it will return the CID for the file which has the actual data. Now I can make a new file and get a new CID. Then we publish that CID. When we resolve that same interplanetary name service hash, we will get this new CID, which contains the new data. So next, what I need to do is create a smart contract that we can store these interplanetary name service hashes. Here I've got the Remix IDE with a simple smart contract. We have a mapping for CIDs. This will be where we store the interplanetary name service hashes. And then we have a function get users, which returns the addresses that have hashes stored. And then we have a function add file, which add a interplanetary name service hash to the mapping. Let me compile this, and now let me deploy it on one of the newer Ethereum testnets. Deploy, wait a moment, and then copy the address. Let me just note down the compiler. So, alright, now I need to fill out the Web3 functionality. So I need to connect the wallet and then connect to the contract and then write out the functions to interact with the contract. Okay, so I've filled out the Web3 code. So I am using Web3 modal. If you go to the Web3 modal GitHub and then to the branch 1 README file, it will show you what you need to import, what settings you need, and how to connect. So I have put that into the JavaScript file. I'm connecting to a Ethereum testnet, and then I've fleshed out the start function. So instead of just initiating the interplanetary file system node, we're first going to initiate the Web3 and set up these event listeners. Then we're going to initiate the interplanetary file system node. Then it sets up the contract as well. For the contract, you just go to the Web3 documentation, scroll down to contract, and that shows you how to initiate the contract. Then to call functions on the contract, scroll down to methods. We've got contract add file, which is calling this function here. Then we've got contract get files, which calls get users, this function here. And then it iterates through the response and gets the interplanetary name service hash, which is mapped to the address. Click start. Create a bunch of data to put into my file. Write that to the file. Get this CID. Then publish the CID and get the IPNS. Then we can go down to a text input that I added is then just going to call the function which adds it to the contract. Submit. Wait for the transaction to complete. Now I've got this button here which calls get files from the contract. So then from the contract, we get an array of IPNS, which then we can resolve, and that gives us the original IPFS CID. So the next thing to do is to create a function which can then synchronize the object data. Okay, so I've implemented a merge function. Let's see how it works. Get the IPNS hashes from the smart contract. So if I resolve this, I get this CID. Now if I cat this, I will see that it's got this JSON object inside with message A, message B, and message C. So now if I create some more data, and then I will hit this button here, merge, which calls a function imaginatively called merge. So we get a copy of the data object, the local data object, and we get a copy of the array of IPNS hashes. And then we loop through each one of the IPNS hashes. And for each one, we resolve to the IPFS CID hashes. And then for each one of those, we cat the contents. The contents of the files will be returned as arrays of data. Then we have to encode that data into ASCII and then pass that into a JavaScript object. And then for each key, we're going to add it to our object of messages if it doesn't exist. And there we go. We've now got a new object with the messages C, B, and A, which comes from the smart contract. and it also includes the new messages G, H, and F. You can then get that data, write that data to a new IPFS file, and then publish. One thing that I would definitely do would be to purge data from the object based on some timestamps, so that just to make sure that the JSON object never gets above, say, a megabyte or something. So what we have here is quite a neat way to synchronize a document database using a smart contract as an intermediary.